Hi everyone, so today we're going to be continuing our HEC-SSP tutorial series, and we are going to be performing a low flow frequency analysis in HEC-SSP. So the first thing you want to do is have your old study open where we did our Bulletin 17C analysis. We're going to go ahead and add on this low flow frequency analysis to it. So the first thing we want to do is we want to add some more data because this annual peak data is not the same data that we need to use for our low flow frequency analysis. We're going to go ahead and click on data, and we're going to right click and create new. I'm going to call this low flow frequency data. I'm going to make sure that the data type is time series, select the location as the USGS website. I'm going to make sure that my data type is not annual peak data, but daily data. And then I'm going to retrieve the period of record. I'm going to retrieve the data for flow. I'm going to make sure that my time zone option is whatever I need it to be. I'm going to keep it as this local standard time. And then I'm going to go ahead and get USGS station IDs by state. Again, navigating down to Virginia, pressing OK. It's going to tell me that it has pulled 834 gauge locations. And then similar to how we pulled the data from the bulletin for the Bulletin 17C analysis, I'm going to go ahead and type Johns Creek into the basin name. It gives me one option, which is the one that I want. So I check the import data box and go ahead and import to study DSS file. All right, and once that has been retrieved, as we can see, this data folder is now populated with our low flow frequency data. So we're going to go ahead and save, and then we're going to start creating our analysis. So the type of analysis we want to use under this analysis folder is the volume frequency analysis. This is the type of analysis that you use for a low flow frequency analysis because it will take a series of data and it will split it up into durations and make certain averages. So that's exactly what we want, things that we learned in lecture so far. So I'm going to go ahead and press new. I'm going to name this low flow frequency analysis. And then I'm going to choose my data set. And so it only gives me one option, which is the data that I just input. So I'm going to go ahead and press that. And what it's doing right now is it's actually dividing up all of my data into separate durations, taking those averages, and then finding the minimum or maximum over that year. So as I can see, I'm going to go, again, sequentially through these tabs up here. I'm going to start in the general one. So the log transform, it depends on what sort of distribution we're going to be using. I know for the purposes of this tutorial that I want to use the log Pearson 3. But obviously, if you wanted to use something like a normal distribution or just the regular Pearson 3 distribution, you would go ahead and change this to do not use. So use log transform, maximum or minimum. Obviously, this is a low flow analysis, so we're going to change it to analyze minima. For the year specification, we want to make sure that we are not choosing water year or calendar year. So the low flow year is totally different from both of those. So the low flow year starts on April 1st. So what we're going to do is we're going to actually change the starting date. And we're going to navigate all the way up to April. And then we're going to make sure that we go back to 1927. So our period of record starts in October of 1926. Obviously, April of 1926 is earlier than that. So we want to be still within the period of record, choosing April 1st, 1927. Go ahead and press OK. The plotting position, we can use the same one that we learned about in class, the Weibull plotting position. And we don't have to do anything over here with extracting this time window, but say, for example, you didn't want maybe the first 30 years of the period of record, or you wanted to exclude the last 20. You could obviously change the DSS range here. Same thing with the season. You could change a season subset here. So after all of those have been decided, we're going to go over to the Options tab. And then we're going to go again sequentially through and see what we need to change. So flow durations, if maybe I wanted to do a longer duration, I wanted to see what the 120-day low flow was. You can click this button and add or change values to your durations. So that'll basically create more curves on your plot. The output frequency ordinates, we want to make sure to check use values from table below. And if we want to change any of these values, we can go in and just double click and edit them if we would like. But I'm going to keep them as is. I think those are fine. Historic period data does not apply to us. It's only used with our 17B procedures, so we can go ahead and skip that. The high outlier threshold, we're not going to do anything with this here, but just know that it does exist where you can override this calculation. And output labeling, we don't want to change these labels. Flow and CFS, these are completely fine for our purposes. So duration table, this is where we see all of our different data points for the entire period of record. So I'm going to go ahead and press extract volume duration data. Basically, this popped up when I selected minima instead of maxima. And that's because when I first selected my data set, it automatically went through and calculated all of my data points based on the maximum for each year, not the minimum. So when I did change it, now I need to go ahead and extract this volume duration data again. So it's going to go through the different durations and it's going to write out my DSS. And now I can go over to the analytical tab, and this is where I'm going to input my distribution and some more information that's going to help me compute my curves. So we have about 3 options here for distributions, and I'm going to use the log Pearson 3 for the product moments. These values come with the log Pearson 3. So I'm going to just keep them as is. This high outlier test we can keep as none, but just know that you could use this 10% significance. Use station skew. This is fine for our purposes. We don't know what the weighted or regional skew would be. This is all we have to do at this point, so I'm going to go ahead and press compute. All right, so once I've actually computed my data, now I can go ahead and output my data. So similar to how we did the Bulletin 17C analysis, I can output a graph and I can also output a report. So I'm going to do the graph first. So the selection I want to make down here is actually plot analytical curve. So this is going to give me my actual curves from my analysis. So I can see I have data points and then I have actual curves. And it has all of my durations all in a different color. And again, very similar to how we printed for the Bulletin 17C analysis, I can go up to File and I can click Save As a PNG or a JPEG, and also print if I would like to do that. And the next thing we can do is we can view report. So I can go through and I can look at what all of my input data was, maybe what my period of record was. And then I can go through and look at all of my different data points. And again, to print this, go up to File, we can Save As or Print to PDF. All right, and that is how you perform a low flow frequency analysis in HEC-SSP.